Alright, as you're working your homework from this first part of section P3, I think you'll be able to do most of this. I wanted just to point out a few questions I know that most students have, so if you want to go ahead and check your answers for 1 through 13, you can. I'm going to go ahead and go to 15. Of course, you can stop this video anytime that you want. 15 has a number and a variable under the square root, so you're going to ask yourself, is the number a perfect square? And as you're thinking through your list of perfect squares, you've got 4 and 9 and 16 and 25 and 36 and 49. So we don't see a 45, so we know 45 is not a perfect square. So then you're going to take the largest factor of 45 that is a perfect square. That's going to be your 9. And you're going to rewrite 45 as 9. One of your factors always has to be a perfect square. You're not doing anything to simplify the problem if you're under a square root. So you have to factor out a factor that's a perfect square. When you get to the variables, this is the main reason I picked this problem, is when you get to the variables, I want to make sure you understand how to take a radical of any variable, because it doesn't matter whether it's a square root, cube root. So if there is no index written, then it is okay to think of this as a square root. So you would think of an imaginary 2 being there as the index. So you're going to say, what times itself 2 times is 9? That's 3. So that comes out. What times itself 2 times is 5? There's nothing, and 5 has no factors that are perfect squares. Then you're going to say, what times itself 2 times is x squared? Well, you can think of that, or you can do the shortcut, which is dividing the index into the exponent. So 2 goes into 2 once, so x to the 1 comes out. If nothing's left over after the index divides into the exponents, you just cancel that out. So we're left with a square root of 5. And then your answer is 3x square root of 5. If the textbook is putting in absolute value, like if they write this problem 3 absolute value of x square root of 5, it's okay to have that absolute value. I'm just not going to make you put that in your final answers. So as you're checking in the back of the book, you can just ignore the absolute value bars and just check your answer like the absolute value bars were not there. Alright, same thing with number 19. There is an index. It's just understood 2. You divide the index into the exponent. That goes 1 time. So x to the 1 comes out. This time 2 is not going to divide into 3 evenly, so there will be a variable left under the radical. Anytime the index does not divide into the exponent evenly, there will be a variable left under the radical. And once 2 goes into 3 1 time, then there's 1 left over. So you have like these understood 1s on your x's, except when you check the back of the book, they're just going to have x squared of x. So 2 goes into 3 1 time. That's where this 1 comes from. 1 is left over, so you have that x to the 1 left under the radical. It's left over, so it's left under the radical as the exponent under the radical. Most of these are worked out for you. Just a reminder, if you're multiplying, you can multiply a square root times a square root. You just have to put those numbers back underneath the square root. So 2 times 6 is 12. X squared times x, add the exponent, is 3. Is 12 a perfect square? No. The largest factor of 12 that is a perfect square is 4. So we're going to break 12 down into 4 times 3. Bring down the variable. Square root, what times itself 2 times is 4. That's 2. Square root of 3. Can't take the square root of 3. When I get to my x, I want to divide my index into my exponent. So 2 goes into 3 once. 1 is left over, so you end up with an x to the 1 under the radical along with your 3. So you have 2x squared of 3x. I think I worked all these out, giving you a few little notes. You can check those. There were just a few that I wanted to kind of explain to you, things that I know that some students usually have trouble with. I think I did those. Alright. 49 and 51 and I believe 53. There we go. we are not allowed to have radicals in the denominator. And you had some previous problems to 49 where you just had one term in the bottom and it was a radical. So these are different because there's two terms in the bottom, and one of those terms, or it could even be both of the terms, have a radical over them. So anytime you have two terms, you have a binomial in the bottom, and one or both of those terms has a radical in it. When we go to rationalize, we have to rationalize a different way here. So we have to have a 3, we have to have a square root of 11, and we have to have the opposite of the sign that's in the original problem. So that's a plus, we got to have a minus. And then if we multiply by 3 minus the square root of 11 times the bottom of our fraction, we've got to multiply the top by the same thing to keep the fraction equivalent to the original problem. So whatever you multiply times the bottom, you got to multiply times the top. So then you do top times the top. We're distributing here. It gives us 39 minus 13 square root of 11. Actually, I think the book leaves it as 13 parentheses 3 minus the square root of 11. That's okay. I'm going to show you both ways. On the bottom, we have a binomial times a binomial, but technically we would FOIL this out. Okay? Technically we would FOIL this out, but this is what we call conjugates when we have two binomials that are exactly the same. And what's going to happen is when we FOIL this out, the two inner products are going to cancel. And all we have to do with conjugates as far as multiplying is we only have to multiply the first two terms and the last two terms, because everything else, if I did it the long way, actually would cancel out. So that's going to give us 9 minus the square root of 121. Same thing over here. 9 minus the square root of 121. And that's going to give us 39 minus 13 square root of 11. The square root of 121 is going to turn into 11. So you're going to get 9 minus 11, so you're going to get negative 2. As long as the 2 will not divide into the 39 and the 13, you can actually leave your answer just like this. Same thing's going to happen over here. And you would say as long as the negative 2 does not divide into the 13, you would leave your answer like this. So either one of these is okay. So same thing here. You have a binomial in the denominator. It has a radical in it. We can't have radicals in our denominators. So we're going to multiply by exactly the same thing, except we're going to change the sign in between. Those are called conjugates. Those binomials are called conjugates. Whatever you multiply times the bottom, you're going to multiply times the top. I personally like to distribute this 7, and that's the way that I'm going to work it, because I know later on that's what you would do. So I'm going to distribute. I'm just going to work it one way. And square root of 5 times square root of 5 is square root of 25. Again, we're doing this to get rid of the radical in the denominator. So then that's going to give me 5. Square root of 25 is 5. 5 minus 4 is 1. So you're going to end up with just a 1 on the bottom. And then your answer is going to be 7 square root of 5 plus 14. Same thing for 53, except you just happen to have two radicals in your binomial. No big deal. Still follow the same process. You take the square root of 5. Instead of being plus the square root of 3, you're going to do minus the square root of 3. So a binomial that's exactly the same except for the sign is called conjugate. And then we're going to multiply top times the top and bottom times the bottom. Again, what this process does is it gets rid of all of the radicals in the denominator. That's why you're doing it. So that's going to end up being 5 minus 3. So that's going to end up being 6 square root of 5 minus 6 square root of 3 divided by 2. And this is going to be your answer unless the number in the bottom will divide into the numbers that are in the top. Not the numbers under the radicals, but the numbers in front of the radicals. So this is going to end up being 3 square root of 5 minus 3 square root of 3. And the book is going to have the 3 out in front. And it's not going to have the 3 distributed, which I like the 3 distributed. I think it's simplified, but I'll take either one of these. Alright, hopefully this will help you with your homework and help our process go a little bit quicker.